Hi, my name is Hayley, and I'm going to talk to you about the effects of altitude training on hemoglobin mass. Before we dive in, I think we should review. Hemoglobin is an iron-containing protein found in red blood cells and is responsible for carrying out most of the oxygen in the blood. So how much oxygen are we talking about? It's about 20 milliliters of oxygen per 100 milliliters of whole blood. Well, why is that so important? Oxygen transport is the limiting factor of an individual's VO2 max, which is determined by cardiac output and the arteriovenous oxygen content difference, or CaO2-CVO2. And that CaO2-CVO2 content difference is dependent on the hemoglobin concentration. Wait, what? Okay, let's break it down. Hemoglobin concentration determines the arteriovenous oxygen content difference, which helps characterize, along with cardiac output, an individual's VO2 max, which describes the maximum oxygen carrying capacity of the individual, which is the role of hemoglobin. Basically, everything is interrelated. That's just some general information that I'm sure we've all heard as kinesiology majors. Real quick, let's define total hemoglobin mass. It's the absolute mass of circulating hemoglobin in the body, and it, in conjunction with plasma volume, determines the concentration of hemoglobin. Total hemoglobin mass and plasma volume are responsible for 97% and 3% of the oxygen being carried, respectively. Total hemoglobin mass makes a very large contribution. Hemoglobin concentration is directly related to changes in erythropoietin, which is a natural adaptation that the body undergoes when exposed to high altitudes. To further break it down, traveling to high altitudes increases erythropoietin, which increases your hemoglobin concentration, which increases the oxygen carrying capacity in the blood. During my research, I came across a study by Jonas Sagi that compared the results obtained after subjects were exposed to hypobaric hypoxia and normobaric hypoxia. Hypobaric hypoxia is going to be your real altitude, meaning that an individual is physically going up somewhere like Lake Tahoe and spending a significant amount of time at altitude. Hypobaric hypoxia is described as low pressure, low oxygen. Normobaric hypoxia is normal pressure, low oxygen, and has been deemed as fake altitude. An example of normobaric hypoxia are hypoxic chambers in labs that are used to simulate altitude exposure without actually traveling anywhere. The results of Sagi's study showed that hemoglobin mass increased in both situations, the one where they were exposed to real altitude and the one who was exposed to simulated altitude, but increases were higher in those exposed to real altitude. An important side note I want to make is that in order to see any physiological changes, an individual needs to be exposed to an altitude of at least 1,800 meters. A lot of the research articles I read discussed a connection between hemoglobin mass and VO2 max. Results varied quite a bit in terms of VO2 max. All studies showed that hemoglobin mass increased while VO2 max either increased, decreased, or went unchanged. I selected a few studies to examine how this topic can vary. The first study was done by Physiological, who was published in the Journal of Sports Medicine. The basic method of the study was to have an experimental group who trained at hypobaric hypoxia for 3 weeks, completing a high-high-low protocol, and their training volume was about 30 hours. The control group did the same type of training, but they stayed at sea level. Zuba's results showed that the experimental group did not improve their aerobic capacity despite there being an increase in hemoglobin mass. The next study was by James Otto, and his publication is featured in the Public Library of Science. This study was different from the others because instead of the athletes being exposed to altitude, they were administered recumbent human erythropoietin, which has a direct relationship with hemoglobin. The athletes' hemoglobin mass increased, and so did their VO2 max. The final study by Sebastian Diebel had subjects in the study spend 10 days at an altitude of 1,828 meters, completing training studies that were similar to the ones they did at sea level. Diebel compared the results before and after their exposure to altitude, and their VO2 max values were lower post-altitude exposure. Diebel suggested that a lower VO2 max was the result of an improved running economy, which, if we need a reminder, is the measured amount of energy required to run at a specific speed. After a considerable amount of research, it has become clear that quite a bit of it is inconclusive about how beneficial an increase in hemoglobin mass due to altitude exposure really is. My point being, why do all these studies show varying results? Why does VO2 max increase, decrease, or not change at all? What is the limiting or increasing factor that determines whether VO2 max will change? These studies had very little to show in terms of an explanation as to why there are so many varying results floating around. I think that conducting a study to explore the reasons behind changes in VO2 max would be beneficial to the exercise science world. Besides its increase in O2 carrying capacity, improvement in hemoglobin mass has little impact. A lot of studies varied in their methods, and there are two factors that really determine when and how adaptations occur: how long the subjects were exposed to altitude and how high the altitude was. So what do I want to leave you with? Even though hemoglobin mass's relationship with VO2 max has showed varied results, I still think it's important to recognize some other benefits that come from altitude training. The first is an improved running economy, which we have already previously discussed. Improved respiratory exchange ratio, which means that if the exchange ratio is increased, the body is using more carbohydrate. Improved performance, for example, completing an exercise test before reaching maximum exercise capacity. Reducing energy costs by reducing oxygen demand. And lastly, an improved muscular buffering capacity, which is the ability to neutralize acid that accumulates during high-intensity exercise, thus delaying the onset of fatigue and is beneficial to anaerobic performance. All right, I hope you enjoyed the presentation. Thank you.